Hello students and good morning. So now I am doing class for class 11. So today's topic is the new topic, that is trigonometrical ratios of compound angles. And in the last online class we finished trigonometrical ratios of associated angles. So I think you have understood that chapter, and I think you have revised all the problems that we did so far in that chapter, that is trigonometrical ratios of associated angles. So now today we will do the new topic, that is trigonometrical ratios of compound angles. So what is meant by compound angles? So you know that if you write only sine A, sine B, sine C, etc., all these are single angle, isn't it? This is known as simple angle. This is known as what? Simple angle or single angle. These are all single angle. Okay, this is also single angle, or this is also known as simple angle. Simple angle or single angle. If you have only sine A, if you have only cos B, if you have only sine C, if you have tan A, if you have tan C, there is only an angle is there. That is known as simple angle, or it may be single angle. Now today we'll discuss about these compound angles. So what type of angles are known as compound angles? Like if you have A plus B, A minus B, A plus B plus C, or it may be A plus B minus C, it may be A minus B plus C, that is known as what? Compound angles, etc. are known as compound angles. So this type of angles, that is, it may be A plus B, it may be A minus B, it may be A plus B plus C, it may be A plus B minus C, maybe A minus B plus C. All these type of angles are known as what? Compound angles. So now today we will learn about what is sine of A plus B, what is cos of A plus B, what is sine of A minus B, what is cos of A minus B, what is tan of A plus B, what is tan of A minus B, what is cot of A plus B, what is cot of A minus B, and so on. Okay, so first of all let us write down the formula, then we will prove it. Okay, so let us write down the formula first. Okay, so formula regarding trigonometrical ratios of compound angles. Okay, so number one is sine of A plus B is equal to, its formula is sine A cos B plus cos A sine B. This is the formula. So sine of A plus B, sine of compound angle is there, sine of A plus B, and we have converted it into simple angles. Okay, that is sine A cos B plus cos A sine B, right? So number two formula is, it is cos of A plus B. Let us write cos of A plus B. Its formula is cos A cos B, but in this case, in case of sine of A plus B, if there is plus, there is plus. But if it is plus, it should be minus in cos. So what is cos of A plus B? Cos A cos B minus sine A sine B. Is that clear? Next, number three. Now sine of A minus B is equal to, it is sine A cos B minus cos A sine B. Cos A sine B. And then number four is cos of A minus B will be equal to cos A cos B. But in this case, if there is sine of A minus B, there will be minus sign. But if it is cos of A minus B, there will be plus. Is that clear? So what is cos of A minus B? Cos A cos B plus sine A sine B. Cos A cos B plus sine A sine B. Okay. Next, number five. Number five is tan of A plus B is equal to, its formula is tan A plus tan B divided by 1 minus tan A tan B. That is, what is the formula for tan of A plus B? It is tan A plus tan B divided by 1 minus tan A tan B, right? And number 6, it is tan of A minus B is equal to, it is tan A minus tan B divided by 1 plus tan A tan B. It is 1 plus tan A tan B. Is that understood? So next, number 7, cot of A plus B, which is equal to, its formula will be cot A cot B minus 1 divided by cot B plus cot A. What is cot of A plus B? Cot A cot B minus 1 divided by cot B plus cot A. Number 8, cot of A minus B is equal to, its formula is cot A cot B plus 1 in the numerator divided by, it will be cot B minus cot A. It is cot B minus cot A. Is that clear to all of you? So I think you have understood it. What is cot of A plus B? Cot A cot B, there will be minus in the numerator. Minus 1 divided by, it is cot B plus cot A. What is cot of A minus B? Cot A cot B plus 1 divided by cot B minus cot A. Okay. Then number 9, let us write down the formula for tan of A plus B plus C is equal to. So let us write down the formula for this tan of A plus B plus C. It will be tan A plus tan B plus tan C minus tan A tan B tan C. Then you have to write tan A tan B tan C, this whole divided by, and in the denominator you write 1 minus tan A tan B minus tan B tan C minus tan C tan A. So this is the formula for tan of A plus B plus C. Okay. And next one is number 10. Sine of A plus B into sine of A minus B, which is equal to, its formula will be sine square A minus sine square B, or it may be, you can convert this sine square A into cos square A and sine square B into cos square B by writing 1 minus sine square A and 1 minus cos square A and 1 minus cos square B. And if you simplify it, you will get cos square B minus cos square A. Is that clear? So there are two formulae for sine of A plus B into sine of A minus B. That is, one is sine square A minus sine square B, and the other one is cos square B minus cos square A, right? So number 11, cos of A plus B into cos of A minus B, which is equal to, its formula will be cos square A minus sine square B, or it may be, I already told you that cos square A can be written in terms of 1 minus sine square A, and this sine square B can be written in terms of 1 minus cos square B, and if you simplify it, you will get cos square B minus sine square A. So these are the formula that you should remember, okay, for this chapter, trigonometrical ratios of compound angles. Now we will prove all this formula. First of all, we will prove these two, then after that two, and this formula can be derived from this formula. Okay, so you can copy it. You copy all the formula and you memorize, and you have to memorize all this formula in order to do the problems. Okay, so you have to memorize all the problems now to do the problems. Okay, so you can copy it. So now we will prove these two formulae. That is, question number 1, prove that you may get the question like this also. Prove that number A, sine of A plus B is equal to sine A cos B plus cos A sine B, and number B is cos of A plus B is equal to cos A cos B minus sine A sine B. So let us prove these two results first. Okay, then we will prove sine of A minus B and cos of A minus B formulae. Is that clear? So now let us prove it. You may get the question like this. Prove geometrically that sine of A plus B is equal to sine A cos B plus cos A sine B, and cos of A plus B is equal to cos A cos B minus sine A sine B. And in order to prove these two formulae, let us draw a figure here. You have to take a revolving line. Revolving line means the line which revolves in a plane, right? So let us take a revolving line. Suppose this is a revolving line OX. Suppose OX is a revolving line which revolves along the plane, right? So let OX be a revolving line. Suppose it revolves and traces out an angle A. Suppose this is OY. Let OX be a revolving line. Suppose it revolves and traces out an angle XOY is equal to A. So it is revolving in anti-clockwise direction. This direction is known as positive angle. This anti-clockwise direction, this OX revolving line is revolving in anti-clockwise direction, and this anti-clockwise direction is known as what? Positive angle. Suppose it traces out an angle XOY is equal to A. Suppose this OY line, suppose it revolves further and traces out another angle OZ. So you have to use ruler and pencil, okay? While drawing this figure, use ruler and pencil. Is that clear? Let OX be a revolving line. It revolves and traces out an angle XOY is equal to A, and then again revolving further traces out another angle YOZ is equal to B. Is that clear? So here OZ is the final line in this case. So I hope you have understood this figure. So let us write here. So this is the proof. Let OX be a revolving line. Let OX be a revolving line. It revolves and traces out angle XOY is equal to A, and then again revolving further, and then again revolving further traces out another angle YOZ is equal to B. Another angle YOZ is equal to B. Okay? So now you have to do some construction in this figure. So here OZ is the final line. So you take a point, you take any point P on this line OZ. You take any point P on this line OZ, and from P you draw a perpendicular upon OX and OY respectively. These are two perpendiculars. This is PQ and this is PR. So any point P is taken on the line OZ, and from the point P the two perpendiculars PQ and PR are drawn upon OX and OY respectively. Is that clear? So let us write here, on the line OZ, any point P is taken. Any point P is taken. From the point P, from the point P, comma, two perpendiculars PQ and PR are drawn upon OX and OY respectively. OX and OY respectively. OX and OY respectively. Okay. Now again you have to do the construction there. Now again from the point R, you draw two perpendiculars upon OX and PQ respectively. This is RS and this is RT. Is that clear to all of you? The figure will be like this. Okay. So now again from R, two perpendiculars again from R, two perpendiculars RS and RT. RS and RT are drawn upon OX and PQ respectively. OX and PQ respectively. Is that clear? Again from the point R, two perpendiculars RS and RT are drawn upon OX and PQ respectively. So I think you have understood it. Okay. So now in the figure you have to write down some angles out there. So in the figure you know that this TR, this is TR and this OX, they are parallel to each other, isn't it? This is TR and this is OX, and OR cuts them. Okay, so let us draw it here. This is your TR and this is your OX and this is your OX. They are parallel to each other, isn't it? This TR and OX are parallel to each other and OR cuts them. And this OR cuts them. Is that clear? This is OX and TR are parallel to each other and OR cuts them. So you know that these are two alternate angles. These two alternate angles are always equal. So if it is A, this one is also what? A. Is that clear to all of you? So this one is also what? This one is also A. Is that clear? That is angle ROS is equal to A. So angle TRO is also A. Is that clear? Next. Next, what is this angle? This angle will be 90 degree minus A, because PR is drawn perpendicular upon OY. This PR is drawn perpendicular upon OY. So PRO is 90 degree. So what is angle PRT? That is 90 minus A. What is angle PRT? That is 90 minus A. You know that, isn't it? This angle TRO is equal to A. So what is angle PRT? It is 90 minus A. And what is this angle? This angle is 90 degree. So now can you tell me what is this angle now? What will be this angle now? What will be this angle? So let us find it. So you know that angle TRO angle TRO is equal to angle ROS is equal to A. These are alternate angles, and alternate angles are always equal, right? Therefore, in triangle PTR, we have angle PTR plus angle PRT plus angle TPR is equal to 180 degree, isn't it? That is, sum of the three angles of a triangle is 180 degree. So here PTR is a triangle. PTR is a right angle triangle, isn't it? This triangle PTR is a right angle triangle, and in this case angle PTR is equal to 90 degree, angle PRT is equal to 90 minus A. So you have to find out angle TPR. So we have to use this property of triangles, that is, sum of the three angles of a triangle is equal to 180 degree, right? So, or what is angle PTR? What is angle PTR? It is 90 degree. Plus, what is angle PRT? What is angle PRT? It is 90 minus A. It is 90 minus A plus angle TPR is equal to, it is 180 degree. So I think you have understood it. Okay. So, or what is 90 degree plus 90 degree? 180 degree. Minus A plus angle TPR is equal to what? It is also 180 degree. So here 180 degree will be cancelled. So or angle TPR is equal to what? It is A. So angle TPR is equal to A. So this angle TPR is also A. So I think you have understood it. So what is angle TPR? That is also A. Is that clear? So now we have to prove these two results, that is sine of A plus B, and you have to prove cos of A plus B. Their formulae should be proved. Okay. So in order to prove this formula, let us take the angle A plus B, and you have to consider this right angle triangle POQ. So this whole angle is what? This is A plus B. Now we have to consider this whole angle, that is your A plus B. Is that understood now? So we can copy it. Now we will prove that result. Sine of A plus B and cos of A plus B. Okay. So you can copy it. So now let us prove first sine of A plus B, right? So now first of all you prove sine of A plus B. So in order to prove both the formulae, sine of A plus B and cos of A plus B, you have to consider a right angle triangle POQ, right? So let us write here, in right angled triangle POQ. So let us prove first sine of A plus B. Sine of A plus B is equal to, what is the formula? It is perpendicular by hypotenuse. Okay. So in this case, triangle POQ is considered. That is a right angle triangle POQ is considered. And in this case, again this angle A plus B is considered. And the side opposite to this angle A plus B will be the perpendicular. This PQ will be the perpendicular, OQ will be the base, and OP will be the hypotenuse. The side opposite to the angle considered will be the perpendicular. ठीक sir? The side opposite to the angle considered will be the perpendicular. That is, PQ will be the perpendicular, OQ will be the base, and OP will be the hypotenuse. Is that clear? So let us write here, therefore again, sine of A plus B is equal to, what is the perpendicular here? PQ. PQ is the perpendicular, and what is the hypotenuse? OP. OP is the hypotenuse. Okay. So now again from the figure, what is PQ? Now this PQ will be equal to PT plus TQ, isn't it? So let us write here. Therefore, sine of A plus B is equal to, what is PQ? From the figure, it is PT plus TQ divided by OP. PT plus TQ divided by OP. Is that clear? Next, again, what is TQ? TQ is equal to RS from the figure, isn't it? From the figure, we can write TQ is equal to RS. So let us write here. Therefore, sine of A plus B is equal to, PT is kept as it is, plus what is TQ? What is that TQ now? So here from the figure, TQ is equal to RS. So we can write here RS divided by OP. Is that clear? So instead of TQ, we are writing RS. Okay. So let us separate this term now. Therefore, sine of A plus B is equal to, let us separate this fraction. It is PT upon OP plus, this is RS upon OP. PT upon OP plus RS upon OP. That is, the fractions are separated in this case. Okay. So next, or sine of A plus B is equal to, now PT and OP. So PT and OP, where is it in the figure? PT and OP. This is PT and this is OP, isn't it? This is your PT and this is your OP. Okay. So now, which is the common line of intersection for PT and OP? Which line is intersecting this PT and OP? This PT and OP is intersecting PR, isn't it? We can take PR here because if you take, suppose in this case, this PT and OP is intersecting PR. This both PT and OP are intersecting the same line PR here, isn't it? So if you take PR, this POR is a right angle triangle and this PTR is also a right angle triangle. Okay. So in this case, both these straight lines OP, that is PT upon OP are here. So this PT and OP both are intersecting straight line PR. Is that clear? So we can write here PT upon PR into PR upon OP. This PR is known as the common line of intersection for both PT as well as OP. Similarly for RS and OP, which is the common line of intersection for both RS and OP? That is, which straight line is intersecting both RS as well as OP? RS and OP. This is your RS and this is your OP. That means OR is the common line of intersection. Here PR is also the common line of intersection, but you cannot take this PR as the common line of intersection because PRS is not a right angle triangle. You have to take a common line of intersection in such a way that a right angle triangle should be formed. Okay. So again, look at the blackboard. RS and OP. Which straight line is intersecting both RS as well as OP? So RS and OP are intersecting PR also. But PR is not correct because PRS is not a right angle triangle. But if you take both this straight line OP and RS are intersecting OR. If you take OR, then ROS is a right angle triangle and POR is a right angle triangle. So you can take OR here. So it is RS upon OR into OR upon OP. Is that clear? That is, RS and OP both are intersecting straight line. Which straight line? OR. Because in this case, POR is a right angle triangle and ROS is a right angle triangle. But in this case, OP and RS both are intersecting PR also, but PRS is not a right angle triangle, so you cannot take PR as the common line of intersection in this case. So I think I've understood it. Okay, so let us write here now, or it is sine of A plus B is equal to. Now at the figure, what is the formula for PT by PR? What is PT by PR? This is PT by PR. Okay, so here PRT is a right angle triangle. Here angle A is considered. If angle A is considered, the side opposite to the angle A considered will be the perpendicular. This RT will be the perpendicular, PT will be the base, and PR will be the hypotenuse. Is that clear? So what is PT by PR? This PT by PR will be B by H. B by H means cos A. B by H means what? So what is PT by PR? It is cos A. It is cos A. It is cos A. Is that clear to all of you? Next, what is PR upon OP? So in the figure, you consider PR upon OP now. What is PR upon OP? This is PR upon OP, right? POR right angle triangle is considered. In this case, only angle B is considered. If this angle B is considered, the side opposite to the angle B will be the perpendicular. This PR will be the perpendicular. OP will be the hypotenuse. OR will be the base. So it is PR upon OP. So what is PR upon OP? It is P upon H. So it is sine B. Is that clear? So here you can write it is sine B plus. Next, what is RS upon OR? What is RS upon OR? Now this is RS upon OR. In this case, ROS right angle triangle is considered. And here angle A is considered now. And the side opposite to the angle A will be the perpendicular, you know that. OS will be the base, OR will be the hypotenuse. So what is RS upon OR now? This is RS upon OR, isn't it? So RS upon OR means this is P upon H. So it is sine A. So here we can write here sine A into what now? What is OR upon OP? That is, what is OR? This is OR upon OP. Now triangle, right angle triangle POR is considered. In this case, this angle B is considered. And the side opposite to the angle B will be the perpendicular always. So PR is the perpendicular, OR is the base, and OP is the hypotenuse. Okay? So OR upon OP, that is OR upon OP means it is B upon H. So according to definition, according to formula, what is B upon H? Collie brown here, that is cos B. So this will be your cos B. This will be your cos B. So I think you have understood it. So, or you can write this is sine of A plus B is equal to, what is the formula? What is sine of A plus B is equal to? So sine of A plus B is equal, let us write down this first now. It is sine A cos B plus, then write down cos A sine B. So I think you have understood it. We have proved the first part. So it is proved. So I think you have understood it. So let us prove the B part now. Okay. So I think you have understood it. So you can copy it. Now we will prove part B now. Similarly, you can prove this one number B. Okay, so you have to consider the same right angle triangle in this case, that is in right angle triangle POQ. That is, now we have to write cos of A plus B. Okay, so before that, copy it. So this is part A is proved. This is part A. Now we will prove part B. So same figure is considered now. Now we have to prove cos of A plus B. So let us prove it now. Cos of A plus B. So for this angle A plus B, again the same right angle triangle is considered. That is triangle POQ. In right angled triangle POQ. So same right angle triangle is considered. That is in right angle triangle POQ. Okay. So now let us prove here cos of A plus B. In right angle triangle POQ, cos within bracket A plus B, Collie brown hair. That is, what is cos of A plus B formula? Base upon hypotenuse. So this triangle POQ is considered. In this case, angle A plus B is considered again. And the side opposite to the angle A plus B will be the perpendicular. PQ will be the perpendicular, OQ will be the base, and OP will be the hypotenuse. Okay. So it is base upon hypotenuse, or cos of A plus B is equal to, what is the base here? OQ. So this is OQ upon, what is the hypotenuse? It is OP. Hypotenuse is OP, right? So next, or this is cos of A plus B is equal to, now looking at the figure, you tell me, how can you write down this OQ? From the figure, this OQ can be written as what? OS minus QS, isn't it? It is OS minus QS. So it is OS minus QS divided by OP. It is OS minus QS divided by OP. Is that clear? So again, this QS is equal to TR, isn't it? So from the figure, it is known that QS is equal to TR. So here you can write cos of A plus B is equal to OS minus, what is QS? It is TR. TR divided by OP. So I think you have understood it. Okay. So now you can separate this fraction. Therefore, cos of A plus B is equal to, separate this fraction. It is OS upon OP minus what? TR upon OP. It is TR upon OP. Is that clear? So left hand side, keep it as it is. This is your cos of A plus B is equal to, now OS upon OP. That means you have to find out which is the common line of intersection for OS and OP. That is, which straight line is intersecting both OS and OP, so that a right angle triangle may be formed. OS and OP. So this is your OS, this is your OP. So OR is intersecting both OS and OP, so that a right angle triangle may be formed, isn't it? That means OR. That is OS upon OR into OR upon OP. Then minus sign. Again, which is the common line of intersection for TR and OP? That means which straight line is intersecting both TR as well as OP? TR and OP. This is TR and this is OP, right? This is TR and this is OP. Both are intersecting straight line PR. Is that clear? So here you can write, this is TR upon PR, because here also a right angle triangle is formed. So PR into, this is PR upon OP. Is that clear now? So let us write down again. This is cos of A plus B is equal to, now looking at the figure, you tell me OS upon OR. That is OS upon OR. A right angle triangle ROS is formed. In this case, angle A is considered. The side opposite to the angle A will be the perpendicular. RS will be the perpendicular, OS will be the base, and OR will be the hypotenuse. So this is OS upon OR. That means base upon hypotenuse. So what is base upon hypotenuse? Cos. So it is cos, what is the angle? It is A. It is A into. Now what is OR upon OP now? What is OR upon OP? This is OR and this is OP. In this case, right angle triangle POR is considered. And here angle B is considered. The side opposite to the angle B will be the perpendicular. PR will be the perpendicular. OR will be the base and OP will be the hypotenuse. So what is OR upon OP? OR upon OP is base upon hypotenuse, that is cos B. So this will be your cos B minus. Now what is TR upon PR? What is TR upon PR? Look at the figure. This is TR upon PR. In this case, this angle A is considered. If angle A is considered, the side opposite to the angle A will be the perpendicular. That is, TR will be the perpendicular, PR will be the hypotenuse, PT will be the base. So what is TR upon PR? P upon H, that is sin A. Some people have, that is P by H, isn't it? That is TR upon PR is P by H, that is your sin A. Sin A into, what is PR upon OP? What is PR upon OP? This is PR and this is OP. So here POR is a right angle triangle and here angle B is considered. If angle B is considered, the side opposite to the angle B will be the perpendicular, PR will be the perpendicular, OP will be the hypotenuse and OR will be the base. Okay. So here PR upon OP. So PR upon OP means P upon H, that is your sin B. So this will be your sin B. So I think you have understood it. So what is the formula for cos of A plus B? It is cos A cos B minus sin A sin B. So it is also proved. So I think you have understood this proof. Okay. So again you revise it at home because this is quite complicated for you. This is the beginning of the chapter. It might be complicated for you. Just go through it, revise it. If you again don't understand, then you can ask me. Okay. So in the next online class, we will do another proof, that is for sin of A minus B and cos of A minus B. So this much is for today. So you revise all this formula at home. Okay.